So now we have the tutorial time. We are doing this tutorial jointly with help from Jayashree primarily, and then from Tukka and from Abhijit. Even though I'll start and Jayashree will take over some of the Python parts where she is more proficient, and then I'll take care of some of the Prat parts where I'm more proficient probably, and that's how we'll go. So this tutorial, our objective is to use the classifiers that we have talked about mostly today. I mean, mostly the QDA classifier is what we are going to talk about. So first of all, first point now is to set up the Google Colab. Can we know how many of you have set up the Google Colab by now? So maybe that is the first thing we'll do. We'll come to that in a minute. Then we'll run QDA on Assamese rhythm data. So Jayashree will do it. She will run it on Assamese rhythm data, and she will show you how to do it. And after that, we'll run a Prat script to extract the F0 mean and standard deviation from the data that you have recorded earlier. Then we'll use that sheet of data, which is we have extracted using Prat. Then we'll run a QDA to classify language and gender. So this is all that we are going to do in the 2 hours. Hopefully we'll be able to finish that before time. For this part, maybe I'll just how to set up the Google Colab. There are information here. First of all, I hope all of you have the Gyan classifiers.zip, that particular file. People who are online also can start doing their tutorial here. So anybody who does not have access to this Gyan classifiers.zip file, any problem downloading it? Everybody has got it downloaded? Yeah? Okay. So basically what we want you to do at this point of time is that you unzip the folder, and then inside that you will probably get another folder called Gyan classifier, and inside which there are some files. You don't have to even look at those files as of now. You just copy that file onto your Google Drive, your personal Google Drive. You just drag and drop it there, right? Once you have dragged and dropped it there, your Google Drive should have this particular folder, Gyan classifiers, and then these these three files should be there in the Google Drive. Are online participants able to hear me? Yeah. So how many of you are done with this step now? Have you got the Gyan classifiers folder in your Google Drive at this point of time? Okay. So, and everybody is able to see something like this in your own Google Drive, right? Okay. And then it should show you should show me. Okay. Can we go to the next part now? Okay. So these are the files that we have right now. The Gyan_classifiers folder should have 3 different files now. The QDA rith_data.ipynb, QDA F0 Gyan Prat script.prat. Okay. And now if you click on that, if you click on ipynb, one of the ipynb files, then it should take you to Google Colab. So you should basically get a screen like this. If you are not getting that screen now,
is it opening for everyone?
Okay, so then you are all able to see this kind of code here, right? How many of you know these codes already? I mean, how many of you already know about these codes? Like you can read these codes and understand what is happening here. Okay, so you can already understand what is happening, right? So for the rest, maybe Jayashree can take it up. What is happening here?
Yeah. So for running, so first of all, why we are using Colab is if you need to download Python, and then there might be some version issues or something. So we are using Google Colab. So for running any Python code, we need some libraries. So the libraries used here are NumPy, Pandas, Matplotlib, Seaborn. So NumPy and Pandas are used for the mathematical calculations and manipulation of the data sets. and the Seaborn and the Matplotlib are usually used for statistical plots and visualization. So here first we have to so since Google Colab is running in your online, so we need to mount the data first and then we need to process the data. So for that you have already uploaded your IPN by the Gyan classifiers into your Google Drive. So first you need to read the data. For that purpose you have to first mount your drive so that you can access your Google Drive in your Google Colab, and then you need to load your data. That is, suppose if you have a feature file like rhythmdata.csv, so this is a file where I'm going to show you this file. So you have to load this file to a data frame. Data frame is basically it is a data manipulation variable in Python. So you will load your CSV file to the data frame and then you'll perform the later steps. So for first I'll show you the rhythmdata.csv, how it looks like.
So to show you what is happening here, what we are doing is that our old rhythm data that you have seen already, that we did QDA in one of our older papers. So that data basically we are loading here, but that is exactly not the same data but nearby data. So we are loading it here. She will run it and show you the results, and then afterwards you will work on your own data.
So if you can see, there are 12 columns. So for as sir already talked about QDA classifiers, so we are now going to classify the data. So what we need to do is we need to predict the class of the data based on the region. So you can see the first column, the region column. So this is our target variable, and we need to from column D to column L.
These are our classes basically.
Yes,
what we
these
have
are the
talked
classes.
about.
Yes.
Yeah.
And from column D to column L, these are our rhythm features.
So column B and C we are ignoring for the time being.
Yes.
So we are just going to do it from column A as the class data, right? And then column D to L as the variables that are associated with that. Okay.
So here you can see that I have assigned a particular variable name to all the columns. So we use for QDA we generally need two variables, one for the features and one for the labels. So for that, the X variable, if you can see capital X, this is the features. So here I have used as df.drop. So X should basically contain the commented line. If you can see this percentage V, like column D to the end up to segments per second. So I'll just read out. It's the first one is percentage V, then standard deviation of vowels, then Varco V, SDC, Varco C, NPVI V, RPVI, syllables per second, and segments per second. The rhythm features. I hope you know. So we need these features into our X variable. So this is according to my convenience. I have to include these features, I have dropped the other columns. So you can also use the previous.
So basically what she is saying is that if you look into the this X is equal to df drop here, what she is saying is that out of the 12 columns she does not need these 3 columns as variables. So apart from these 3, whatever is there will be used to train the data, train the classes, sorry, right? And here in Y you have basically the classes which is under the rhythm column, under the region column.
So we need to classify our data based on region. So we are using region in Y variable. So next the sklearn model. This is the basic Python model for so we are using, so for any kind of, as sir already talked, for any kind of classification, first we need to divide our data into training and testing. So here we are, there are inbuilt functions in Python which does it automatically. So I am using the train test split of the sklearn model, and I am splitting the data. So the default training testing size is 75% for training and 25% for testing, and so we are using the random state as 42. So this number does not, this number is just used so that we can reproduce the data every time, the same data. Sometimes it so happens if you don't use this random state, so every time when you run the model, you get different accuracies for your model. So if we like initialize it to this default value, so you'll get the same result every time. So next we proceed to the prediction task based on the features using this quadratic discriminant analysis. This is also an inbuilt function in Python. So we basically fit the model into the training data, and then we make the predictions on the test data. So in the next step we find the accuracy. So the accuracy is based on the test levels and the predictions that you made after training the data. So next step, you for visualizing the accuracy score, what is the confusion matrix? I mean, like which language is getting confused or which language is getting misclassified or classified, how we can visualize it? We can visualize it using a confusion matrix. So Python also has an inbuilt confusion matrix function which does the job, and if you don't include this but this line, so you will just get the confusion matrix in terms of the number of files that you are subjecting to the model. So now if you want the result in terms of percentage, you convert just the values to percentage using this. Next you plot the figure and then the confusion matrix. So these are the inbuilt variables that are used for visualizing the confusion matrix. So here these are some default values, where this annotation true means it gives you the numbers in the confusion matrix. If you can set it to false if you don't need the numbers. So this format is, if you want, as I already said, if you want the format as only the number of files, you can use it as D, and so 0.2 is used for percentage display. And the color blue and the bars, you don't need the confusion matrix in terms of bars, so I have set it to false.
So these are two mostly cosmetic things.
Yes.
So if you don't get all of that, don't worry, because as long as it runs today, that is going to be our achievement basically, right?
So you can see a play button here. So if I,
as soon as you do the play button, then it might ask you for a lot of permissions, like Google will probably ask you a lot of permissions. So choose wisely and give the permissions. So that is, she is only displaying now, right? So let her display, and then we'll give you the other, you'll generate your own file.
Yes. So you can see that the 5 regions, the accuracy is 0.37, 37%. So how you read this confusion matrix is,
can you run it one more time and then show them? Yeah. And then it spits out the result, right?
Yes.
In case of random forest, the next time, every time you run it, you're gonna get different results, because you don't know which decision tree it's going to take the average from. So
in fact, if you don't include the random states here,
yes,
so you will get every time different results.
Okay, so is this fine? So far the dry run is okay. So for everybody, you're able to, like, launch the collab, right? You're all good with that. Okay, great. So then we go to the next part. So now, have you tried downloading the audio folders from the Gyan corpus folder?
Yesterday you received a Gyan corpus folder. So from there, please download the audio folder in your local system. Just the folder, you just
The
click.
if you click on the folder, then it should get the whole folder in zip form probably.
Yes, you get 3 dots. Just click and download.
And just put it on your local system. What is Star Audio? Oh, just R Audio. Okay, yeah. So no, the all audios, whatever you have in that particular folder. Yes.
Right click and download the audio folder itself.
It is the whole audio file, a whole audio folder that is there. So if it is downloaded, then you might like to unzip it, or if it is in zip format, then you want to unzip it and put it in a place from where you can access it. So after you have downloaded, and if you are already like proficient with all these steps so far, please download the gyan-prat-script.prat which is for prat, and then run the prat script. If you don't know how to run the prat script, just wait. So the prat script, you have to download it to your local folder, hopefully.
You have it in your folder, you just need to download it.
How many of you have experience running prat script? Raise your hand. Almost everybody, right? Sorry? So, like now, if you don't know how to run prat script, after you have, can you close it and then we'll do it again? After you have downloaded the script, open your prat, right? And then don't go to open, right? Go to prat, and then here, I can actually click on this maybe, right? Oh no, that is not connected to this, right? New prat, or maybe it is, because they have a HDMI, the USB. Oh no, HDMI, okay. Okay, open prat script. And then find your, yes, the Gyan Prat script. This is an automatic system now. I just speak and it automatically does all the work. So open. And then what happens is that here you can see that, like, the directory, the first directory dollar is basically where your audio files have to be located. So if your audio file, wherever you have downloaded the audio files, that directory name, that directory path, that you go and paste it here. If anybody is using Windows, you might have a problem with the slashes, because in Windows usually the slashes are on the other way, right? But I'm not sure if it is still the case. Still the case, maybe. God knows. Right? So you put the directory path, and that should point to the place where you have saved your sound files. Fine? Okay? How many of you are with me until this point of time? Raise your hand. Yeah, open and then put your path there. We don't need any CSV at this point of time. We are going to generate the CSV. So just wait for a few minutes. We are at prat running stage right now. Okay? Yes, where all the, you basically copy paste the path from there, right? Click on one of the files in your folder, right click and get properties, and get the whole, this thing, whole path, and then paste it there. Fine? Okay. So now, here, there is a line called file append. If you look into this, the next line is called file append. So basically, the directory dollar is where you are reading your data from, and file append is basically you are creating a CSV file where all your whatever you have measured using the prat script will be written. Okay, so find a place like in your desktop or some other folder, and provide that path to that folder where you want to save this your file. Okay, and you can, like, just for simplicity's sake, you can say that you want to create a file called pitch_results.csv, right? It's a comma separated values file, right? So every comma, it will make a column basically. So the same, exactly the same file append line, location here, you can copy and paste on the bottom here. Another file append is there. So you do copy and paste it here. Don't change this file name, language, gender, min pitch, all these things later. Up till only pitch underscore results dot CSV, until that part only you change. Is it clear? Is there a confusion? Yes. So what I'm saying is that here, wherever you want to save your output file, because Prat will do some measurements and put the measurements in a file, right? Where do you want to put it? Let's say you want to put it in the desktop. Then if you are using your Windows system, then it will be C:/ maybe what users or something, then / your name / desktop. Wherever you want to put it, that path you put it here. Yeah, you can just the path, only the path you can change. Pitch results.csv you can keep it, right? And only up till here, from home to this part, you can change.
So
File append should be there, because file append is the command. Basically, it is saying that create a file or add to a file. Can we go to the next step now? Okay. So now the next step is to run the script. Basically, what we are doing at this point of time is that if you have put your directory $ correctly, you are reading your files from the directory, and then you are doing some calculations and then spitting out the results here into the pitch results.csv, and you have to give this file append this location in two places, here and down here. Okay. Once you have finished that part, you can basically go here, click on run, and run the script. And immediately you will have some errors, so don't worry about it. So if it is running, then there should be a file created in the location that you have put it in the file append part, which should say somewhat like this, pitch results.csv. Please double click it and see if there is anything written there or not. Okay. And until this part, until the creation of the pitch results.csv, how many people are done? Anyone left behind? I am being shown this. Now how do I see that? No, I think it's all good. So many. You just go and check if the file has appeared on your location or not. Yeah, in the file append location. So one of the things is that many of these scripts are sensitive to blank spaces. Okay, and in many times when you have blank spaces, it also does not tell you anything. It just keeps quiet and does not do what it's supposed to be doing, but shows that it has done what it's supposed to be doing. So when you have a folder name, don't put a blank space, such as don't put as my blank space name. If you need to separate it, put an underscore. Don't even put a minus sign, because sometimes that also causes a problem. I mean the dash basically. Are you able to find the file now? I think we are just waiting for one online participant probably, right? And rest, we are all good? Okay, so we can go to the next step. Can you just check if the audio files are within that folder, or there is another folder inside that audio 2025012 T10041112-001.
There is another folder.
There is another folder inside that. So I think you have to give another / and / audio or something. You check the third line. So if you are done with the other things, so I just want to draw your attention to a few things in the Prat script. So here, what is happening is that, as you know, it is going to the directory, and then it is reading actually how many files are there in the directory. So let's say you have in total 50 files. It reads how many files are there, and then it asks to get the number of total file names in that folder. As you can see here, number of files is equal to get number of strings. So whenever in Prat scripting, whenever there is a number, the variable name does not have anything following it. whenever the variable is a string or a text, there is a dollar following the variable name. So it is just like, so number of files is equal to get number of strings. So number of strings is always going to be a number, so it does not have the dollar. So here we have a for loop. For loops are basically for like, running something so many times, right? So it is asking that for I file to number of files. That means like, do it for all the files from 1 to end of the total number of files. So what does it do? It basically gets the file name, get the strings file name, and then I'll skip this part. Then what it does is that it selects the first file that appears on your Prat object window and says that to pitch, that convert it to a pitch object, or extract the whole pitch of that sound and put it down there. So on Prat, if you slow down your that going brrr, if you slow it down, then you will see that there is below every sound file there is a pitch file that is being created. So the pitch file is basically like, it is getting the pitch extracted from there and it is putting into like, one line. And then after we get the pitch, so it gets pitch into, let's say first file's name is ABC, then it says that get the F0 is equal to get mean of that whole pitch of that file, and SD is equal to get standard deviation of that whole file. So we are getting two values here for each file, get the mean fundamental frequency and standard deviation of the fundamental frequency on the whole duration. No, can you go back? Okay, after that what we are doing is that we are asking like, what is the language of the file, because remember the first three letters that you have put, right, and the first three letters are basically the language name, right? So that is why it is always good to have very well formatted or like, uniformly formatted file name. So I'm saying that language dollar, because now it is a text information, right? Language dollar is equal to left dollar of the file name dollar comma 3. That means like, go to the file name and get the first three characters of the file name, that is going to be the language name. So it is getting that information. And I'm putting something funny here. I'm saying that if language dollar is not equal to English, ENG, then say other. So I'm not keeping any other, like, your all other languages, Assamese, Bengali, etc. I'm not keeping it. What I'm doing is I'm forcing it that if it is not English, you just change it to other, right? Because now first thing I want to do is a classification between other and English, right, and see if it works, right? So now we have a bunch of, so all that information, and gender dollar is equal to mid dollar of the file name 91. If you look into the file name, then you will see that the 9th letter is the one indicating gender, which is F or M or O, right? And then I'm saying that go to the 9th letter and get one character of the 9th letter. So it is going to be one single character. So it is going to get the F. As you can see, it is getting all the M and F, etc. It is getting language as other. Go down somewhere, please. And here it is English, so it is not changing it. Okay. So we have now got in the first column. Can you go back to the script, please? In the first column here, file append here, if you look into the first column, we are putting the file name, right? It is coming from here. Language dollar is coming from here. Gender dollar is coming from here. F0 value is coming from here. Standard deviation is coming from here. And then I'm asking is that after that, you go to the next line and repeat it for each file. So it will keep on doing it for all the files. Basically, that is what the script is doing. Okay, are we clear about it? Is there a question about it? Right? You don't need to know, but it is always good to know, because then you will be able to troubleshoot some of the, when the script is not running. At least you have an overall good idea about how it is working. So after we did that, now we should get, can you show the Excel file, the CSV file, please? Now we got the CSV file, right? And now we will put the CSV file that you have in your Google Drive again, because now we are going to run our classifier, the QDA classifier, on this file. Fine? Okay. So your Gyan underscore classifiers should now have the results that you have got, the .csv file that you have got, okay? As it is shown on screen right now. If you are done uploading it to the Gyan classifiers folder, are we all done? Done? Okay, super. So now you go to the, where is that? Okay, QDA F0 IPYNB, double click on it, right? And now Jayashree will take over. Everybody, it is open. Anybody for who is not open yet? Everybody, it's open. Great. So
here first the classification, what we are going to classify here, the features are the mean pitch and the SD pitch. So those two will come into our X. As I already said, the features will come into X, and with respect to what we are going to classify, the language, other or English.
So the class is going to be the language,
is going to be
and now
language.
we have reduced it to only two classes, other or English, right? So basically what we are trying to see is that given average F0 and standard deviation F0, will we be able to classify English versus the other languages? Okay? Okay, let's run the code. So look at this. This is important now. So now it says that permit this notebook to access your Google Drive files. Of course, yes, right. But then it wants to know, then it wants to know, do you want me to see your photos? Which is probably not a very good idea. So this is okay, right? So now she has given the required permissions. Usually for me, the first permission worked. I gave only the first permission, it worked. Jayashree, when she worked on that, she had to give first permission, second permission, and fourth permission or something. So I think, I don't know why, but it varies. Maybe they already have my data, they don't need it. Everybody is done?
Yes.
Yeah, you have to play it, but it is actually running the script. But yeah, it is a play looking button. Everybody is good? Does everybody have an error? Yeah? Good. So now we have this error, right? See, like, we know that there is an error. And what is the error? What is the error saying actually? So look at this value error. Y has only one sample in class F. Covariance is ill-defined. Number one. Two things you have already got. See, class, it's also talking about class. Now you already know what class is, right? Second thing it is talking about is that what is the problem? The problem is that there is a class called capital F, right? And because of which it has only one capital F data, I am not going to run this. That is what it is saying, right? So it cannot do any covariance analysis, right? So what is the problem? The problem is that in the data set, go back to the data set now. In the data set, see, we don't have a uppercase F anywhere, right? Nowhere do we have an uppercase F, right? But wait, can you go up a little? See? And look at this. This is ASM underscore PAG underscore F. Somebody has put a, uppercase F, because of which it now thinks that there are actually three classes. Uppercase F, right? So what we need to do? Correct it, right? Make it to lowercase. Okay, another problem that was pointed by you was that some ENG English data is also classified as, labeled as other, right? Can we go and look at it? Okay, look at this. Why is it happening? Because of uppercase E. So this is why we have been saying that you have to be really consistent about how you put your data, your file names, right? How you put your documentation is very, very important in order to run everything correctly. Okay, so let's correct this, and then whatever this capital or uppercase E's are, there we put ENG, 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 ENG. That is all we need to do, right? So just put lowercase ENG because that is all we have. There are two classes only, other, OTH in lowercase and ENG in lowercase. Fine. Similarly, gender also, I think we only have two classes here, probably M and F, right? And then
After saving, you need to upload it again to your Google Drive.
anyway, so whatever way you do it, see? Check. Okay, once the correction is done, let's go for the next step. Basically, you have to run it again, the play button again. Okay, the correction is done. Did you run it again? Okay, everybody is good. So what did we classify there? What is the average, what is the accuracy there? 97%, right? And then, let me see. So you should get something like this, right? And if you look into the code, here, you can already see what is your Y here. Y basically is gender. And you have two classification, right? M and F. So it just, basically trained on the F0 data and saw, whether it can predict or not. As we know, F0 is a big predictor of, gender. So most of the cases, majority of your cases, 97% of the times it got it correctly, right? Now, what you do is that you manipulate the code and make it run for language types. You have two language types, right? So for language, you classify and see if F0 and your SDA or F0 helps. Right. Now you know how to run it, right? You have to get some sort of variables there. You're right. Isn't it true that sometimes system-wise there are system-induced variance also in the results of accuracy sometimes?
I actually don't know much about the QDA classifiers, but I think that the training of them is a stochastic process. I might be wrong here, but in many classifiers, like neural network, it's a stochastic process. So the result might depend simply on sort of random seeding and random sort of running the random variables. I'm actually not sure whether QDA is deterministic or stochastic. We would have to ask somebody, but that might be one of the reasons. Are people getting different results?
No, I think we are different from others, and that may be just one sort of, maybe one set of data that is different. I don't know.
Yeah, or maybe because we were editing the code. So it doesn't seem that the QDA is a stochastic classifier, because it seems to be yielding the same result every time we run it, and there are two types of results around. So there must be the difference in the data. Among all of those editing which we did and all that, they probably have slightly different data.
So people who are online who are wondering what's happening here, the results of the classification was very different from people to people. Then we realized that somebody who we don't want to name now has actually did something with changed the data. So we have a different set of data, and some people may have different sets of data. So nevertheless, so we'll then, I think this is all we wanted to do. So I think the reason why this one is so bad and the other one is so good is clear, because basically F0 is gender dependent. However, language there is nothing to do with F0, right? It might have in some senses, but not at this point of time. It is all the same speaker, so you're not getting any classification here, right? So yeah, so I'm basically doing the tutorial, but I would like to really appreciate the help that I got from Abhijit, Jayashree, and Tukka in in making the tutorial. So they worked really hard until late last night. So thanks to them. And then if you have any questions, so we are still here. So come and talk to us. Thanks. So online participants, we are going to stop the streaming now. I hope everything is good. If any problem is still there, I'm waiting here, or you can just use WhatsApp to contact me. If it is fine with you, then they're asking me to cut the stream now, and so I guess that everybody else is okay with that. Thank you so much for joining. So we'll see you later. Bye bye.